Good evening, ladies and gentlemen. Thank you, Professor Balin, for those kind words. They're a bit exaggerated, and I do hope that I will be able to live up to, the things which you have said about me. It's also my pleasure to be invited here this evening to talk about groundwater and fracking in the Karoo. I realize that this is an issue which is very topical today and something that you and I are grappling with as a country, and particularly those who live in the Karoo. This is something that is of great concern to them. Basically, fracking is essentially a practice where you introduce water, sand, and chemicals into a production well, and in order to be able to extract gases from deep geological formations which we call shales, which are approximately 3,000 meters to about 4,500 meters down the earth. And this particular practice is said to be unconventional because of the fact that you've got to use tremendous amount of pressure to be able to extract the gases which are contained in this particular formations. Those gases are there because they are within a confined under tremendous pressure. So fracking is a practice which tends to dislodge the gases from those confines. And because of the fact that government has given license to Shell to explore, not to prospect, but to explore, about a quarter of the entire Karoo, in fact about 95,000 square kilometers, this issue has now become an issue of concern to every citizen within the Karoo. There are proponents of fracking who believe that indeed it's a game changer for South Africa in terms of its energy needs. And there is a support which has been given to it by the president of this country, President Jacob Zuma, in its February State of the Nation address, in which he described fracking as being a game changer, and that indeed Pretoria is going to support this practice within the framework of good environmental practices. The US is commonly cited as being one of the countries where fracking has taken place. In fact, fracking has met 25% of the energy needs of the United States of America. The opponents of fracking consider fracking to have ecological and environmental consequences, in the sense that it will affect and pollute the surface waters, it will affect and pollute groundwater, it could trigger seismic activities, it could also impact negatively on the flora and the fauna of the Karoo. Opponents of fracking also cite the United States of America, where they see where they have indicated some of the negative impacts of fracking on the ecology and the environment within the United States of America. There is a lot of opposition to fracking in the United States, in Canada, in the UK, in France, and many parts of the world. At the same time, I see the debate to be so emotive that sometimes we miss the facts and we fail to ask the right questions. So I'm hoping that this particular public lecture will help us to have the right frame of mind, whereby we will ask the right questions, we'll engage with the issues, not in an emotional way, but in an intellectual way. I realize that this is a very mixed audience, and I'm going to be very careful to avoid using technical jargons. But for everyone's, for our understanding, I will always refer to boreholes as wells which are located for drinking purposes. And I will refer to wells as production wells for either oil and gas production. That is the kind of nomenclature that I'll be using. Let me try to set the scene in terms of the context. Here we are, here is the map of South Africa. And in this map, you have the Karoo, which is, you can see Kimberley there. Yeah, Kimberley is just about 310 kilometers southwest of the area which has been allocated. This area is the area which has been designated for fracking exploration. And it's about 95,000 square kilometers. The distance is about 310 kilometers southwest of Kimberley. I want to say that every human activity, every single human activity will have some kind of environmental impact. Every human activity. We should be aware of this. There are also benefits which are associated with every human activity. And so, if you look at the scale of development, for instance, if you are at a particular scale of development, that scale of development could be mining, it could be even the construction of this university. It will have certain environmental impacts. And that will be the impact which you have there. Now, if you do nothing, you have what is referred to as the pristine condition, which is this. In other words, situation will remain the way it is. But the moment you have any activity, you have this kind of relationship which is like that. And that depends on the scale of your development. You've had mining here in Kimberley. Mining has had its impact on the environment. But there are also benefits. Here are the benefits. The benefits could be in terms of, if it is with regards to the university, this particular university, the benefits will be in terms of the students who would graduate from this particular university. Now, you also need to realize then that it isn't only fracking that will cause environmental damage or ecological damage. Any human activity will cause some kind of environmental damage. So you've got to weigh the benefits and the risk that is involved. That's why we shouldn't be so emotive concerning the issue of fracking. Furthermore, the same kind of activity that you have could, for instance, have less impact by the blue line. You can see that the blue line, in terms of the impact, is much less than the red line. And the benefits of that as well could be the dashed blue as well. The question then is, what will make a particular situation, for instance, this particular blue line, the one that is here, the blue line, this blue line is better in terms of activity than the red one. The question is, what are the factors which will give rise to either the blue or the red? One of them is the nature of that particular development. The second has to do with how sensitive that particular area is ecologically. And the third thing has to do with adoption of best management practices. There is, if you look at fracking all over the world, for instance, there are areas where fracking has not produced as much environmental damage as in other areas. And that is because of the fact that those companies had adopted very good management practices. So we need to look at fracking from the angle of, is it possible for us to do it properly? The same thing with coal mining, the same thing with diamond mining, the same thing with what's it called, gold mining. Is it proper? Is it possible for it to be done properly? And indeed, there are certain standards which will give rise to good, or what is referred to as internationally best management practices, and those that would give rise to very poor management practices. So I felt I should bring this to your attention so that when you think through the issues of fracking, please understand that there are ways that it can be done properly and that there are ways that it can be done to the detriment of the environment. Let me now focus on the Karoo in terms of the groundwater. If you look at the Karoo here, you will find that this is the area here, I'm having a problem. Yeah, this area is the area where the fracking exploration will take place. In this particular area, the amount of recharge essentially is, recharge has to do, if you don't mind, recharge has to do with how much of rainfall gets into the groundwater. If you look at this particular graph there, you will discover, this particular picture, you will discover that the Karoo receives about 5 millimeters of rainfall that recharges the groundwater. Now, if you compare that with the rainfall, it simply means just about 1/100 of what falls on the earth, on the Karoo, actually gets onto the groundwater. That indicates to you and I that the Karoo, in terms of groundwater resources, is a very delicate system. If you mine the Karoo too much, in terms of if you abstract too much water from the Karoo, it will give rise to a radical fall, a drastic fall in the water table, in which case then many wells will go dry. And that is because it is in a semi-arid or arid region. So we've got to be extremely careful in terms of how we mine the groundwater resources of the Karoo. Now, I want to bring a couple of things which are unique about the Karoo to you, so that you will then appreciate and balance that with the fracking which is being proposed. If, for instance, this activity is being done, say, in Mpumalanga or in, say, the Limpopo, where the rainfall is in the neighborhood of about 100 millimeters per year, it's a different story. If this is being done in the DRC, where the rainfall is about 2,000 millimeters per year, it's a different story. And the recharge of aquifers in those areas are also extremely high. But in the Karoo, if you look at this map, it tells you that the Karoo, in terms of the groundwater resources, is a very sensitive issue. The recharge is extremely low, too low, to the extent that you've got to be careful in terms of how you mine that particular aquifer. Now, I'd like to then go to another graph, another chart, to tell you about this chart. Comes from the vulnerability of the groundwater resources within the entire country. If you have colors, these colors, what's they called? You have a yellow, green, and the brown. The brown indicates areas within South Africa where which are very vulnerable. And this particular Karoo, this area which we're dealing with, where the mining is supposed to be done, I'm having some difficulties with this. You discover that the aquifer vulnerability to contamination is from moderate to high. What this means is simply this, that to contaminate the aquifers or the groundwater resources within the Karoo, it's easy for you to contaminate them compared to other aquifers within South Africa. And so there's got to be a great deal of care in terms of how the groundwater resources is treated within the Karoo. I like to make some bit of comparisons here so that we be aware of certain things. I like to look at resources, 3 different resources. One of them has to do with groundwater. The second has to do with rivers, and the only river within the Karoo is the Orange River. You guys are aware of that. Yeah. And I also like to look at the shale gas itself. If you make some bit of comparisons in terms of these resources, you will discover that the aquifers in the Karoo lie within the region of about 30 meters to about 100 meters down the surface of the earth. Rivers are on the surface of the earth. But the shale gas is deep within 1,500 meters to about 4,500 meters below the earth. That's just some information that we should be aware of. Groundwater resources is regional. It's always spread out over a considerable area of space. When you compare that with rivers, rivers lie on a corridor. Furthermore, if you compare that with shale gas, it's also regional. I felt I should bring all this to you. There are implications to all of this. Furthermore, in the Karoo, when wells are drilled in the Karoo, water tends to rise onto the surface. That is what we refer to as the artesian conditions. And that's why you have about 14 springs within the Karoo. But you all know that you've never seen a river which flows uphill. No one here has ever seen a river that flows uphill. But within the groundwater resources, water can actually rise up when you drill into it. Furthermore, in terms of shale gas resources, gas will also rise to the surface. If you wish to abstract groundwater, the energy requirement is fairly low. Surface water, the energy requirement is almost negligible because it's on the surface. But shale gas abstraction requires enormous amount of energy. When you introduce pollutants into, and this is specifically with regards to the Karoo, when you introduce pollutants within the groundwater resources within the Karoo, it will flow with 2 different velocities. One of them has to do with the fixtures or the fractures that you have within the Karoo, where contaminants and pollutants flow extremely quickly. And we usually refer to that in terms of the arrival times is in the order of months. And these are the fractures within the Karoo. These are the fractures within the Karoo. These ones. These are the fractures within the Karoo. But when you now talk about the flow of contaminants or pollutants within the matrix itself, it takes a number of years for pollutants to flow through. So you may have a fracking activity taking place today. It will show up in terms of, in other words, if there are any contaminants, chemicals which are introduced within the Karoo system, if it flows through what we refer to as the fractures, within some months we might be able to detect it. But if it flows through the main body, which we call the matrix, the groundwater matrix, it could take a number of years. And sometimes we're talking about it could be 10, 20, even 100 years to actually detect whatever chemicals have been introduced. But in terms of rivers, the moment you introduce chemicals into any river, you get to see it within hours or minutes. How about the shale gas itself? Chemicals, if you have chemicals introduced within the shale gas, they flow at very high velocities because of the fact that it's been transported by the gas itself. And you know gas, in terms of movement, is much faster than a fluid flow or water flow. I felt I should bring all this so that you understand these characteristics unique with the Karoo. If you understand this, then there are certain things, there are certain implications. There are certain groundwater systems, for instance, in the world. If you drill into them, the water will never rise. But in the Karoo, the water tends to rise. So let's be aware of this and then take appropriate measures in terms of the movement of contaminants and pollutants as we... If you look at those who use groundwater within the Karoo, most of it is being used for irrigation purposes. Most of it is being used for stock watering. Very little is being used for domestic in terms of, but let's be very careful about these numbers because most people do not register the information with the Department of Water Affairs. This information that I have here is coming from the Department of Water Affairs. So the largest users of groundwater resources within the Karoo are actually the farmers. And I'm sure that's the reason why they're extremely concerned about fracking as an activity. Sorry. Let me just talk about fracking very briefly. Fracking as an activity, you have a production well there. You have a production well. Note that for drinking purposes within the Karoo, most of the wells are within 30 meters and 100 meters, most of the wells. As you go further down the Karoo, the wells produce water which are said to be saline in nature. In other words, they are no longer good for drinking purposes. But you have water, but it's not good for drinking purposes. So between 100 meters to about 300 meters within the Karoo, the water is generally saline. Shale gas, which is within an area, which is a confined area, which is actually a compacted soil matrix, is within a depth of about 1,500 and 4,500 within the Karoo. So what happens is this. Within that layer, there are what we call production areas where you have high gas volumes and areas where you have very low gas volumes. So what happens is that these drilling companies will drill into the underground system and identify areas where you have high gas volumes and then drill the horizontal wells, these horizontal lines. Good. So these horizontal pipes go for about 1 to about 3 kilometers. And those pipes are referred to as the fracts. It is within these, so as you go down this particular system, you've got to case it with steel casing and also cement grouting at the end, at the outer edge before the geological formation itself. So you have all of this taking place. And then thereafter, you introduce water, sand, and chemicals. And under tremendous pressure, in order to be able to dislodge the gas which is trapped within the shale formation. What happens is this. In the process, you then artificially create fractures within the system. You artificially create fractures because those gases are locked in there. You then use the pressure to abstract that gas onto the surface. So that is essentially what the fracking process is all about. And the fracking process, you've got to introduce certain chemicals to be able to dislodge those gases within the system. I said at the very beginning that we shouldn't be very emotional about fracking. We should begin to ask the right questions. And if we ask the right questions, we will be able to address the issues in a very intellectual manner. The first question you should be asking is, where will the water for fracking come from? Where is it going to come from? That's the first question. That's the first question. In terms of what you need to carry out fracking, it's a huge amount of water that is required. A huge amount of water that's required. The question is, where will that water come from? That's the first question we should be asking. Here are the 5 suggestions which were made by the consultant, commissioned by Shell. Here are the 5 suggestions they had. The first one is to use groundwater from deep wells which are located at depths between 100 meters and 300 meters. I indicated to you those wells, or the water in those areas, are actually saline. They're actually saline. So that is the first suggestion. But note one thing. When you use water from those particular formations, they will affect the groundwater which is overlying. So let's be aware of that. Because one other difference we need to know, for instance, we all know what rivers are. None of us has ever seen a river that lies on another river. Are we together? But when we talk about groundwater, we have groundwater lying on groundwater in terms of, we call them aquifers, which lie on aquifers and overlie aquifers and so on and so forth. And they interact with one another. So we should be aware of this. They interact with one another. So when you abstract from these deep wells, if you abstract from these deep wells, although the water is saline, the interaction between the groundwater, which is fresh, and the saline water, the interaction will play a great role in terms of the resources. The other suggestion which was made is to use treated wastewater. Where is that treated wastewater going to come from? How many big cities are there in the Karoo to be able to generate that amount of treated wastewater? The third suggestion which was made is that you need to pump water from a surface water. Which is the only river in the Karoo? The Orange River. The fourth suggestion is to use seawater. In other words, you've got to then maybe use the water from the Indian Ocean or the Atlantic Ocean. And the fifth suggestion is to purchase water from the municipality. Now, I think you guys are all smiling because you can see how ridiculous all these 5 suggestions are. And that's why I say that maybe the first thing we should be asking is, where will the water for fracking come from? That's the first question we should try to address. The second thing that we need to look at is, what are the possible effects of fracking on groundwater resources? There are 3 things we need to be aware of. There is the site, the explorational activities, and then the decommissioning phase of fracking. In other words, where you seal the wells up. So those are the 3 phases, and I'm going to look at the consequences or the effects of fracking on groundwater from these 3 angles. The first has to do with the site. In terms of the site, This is a typical fracking site in the United States. And on this particular site, I have also indicated as well in this presentation what I consider to be significant or a thing of concern, and C, I say it's not a thing of concern. C means concern, and SC means a serious concern. In terms of the impact of your well pad installation to reduce groundwater recharge in the Karoo, it is not something of concern. Why is it not of concern? The reason is very simple. The well pad area is too small compared to the area of the Karoo, which receives recharge. So that is why it's not of concern. The second is leakage from stored poor quality water into the groundwater. This is a typical situation where you store your poor quality water. The poor quality water is water that you use, for instance, say for water, for instance, from the brackish medium. If you, for instance, you are trying to get from the brackish area, or water, for instance, from the sea, if you're going to use that for your fracking purposes, you store them. I don't think, in terms of polluting the groundwater, it's not something of concern. The reason is because even if you have small leaks into the groundwater, it will not significantly impact the quality of the groundwater. The third is storage of drilling fluids and chemicals into the groundwater. Overflow and spillage could occur and infiltrate into the groundwater. This is a typical storage for drilling fluids. That is very significant. That is something of serious concern to me. Because what you do is that you line these storage facilities, and they can easily be breached, and which will cause leakage into the groundwater resources. And I think that is something of serious concern to me. And that is something I think we should try to address in terms of the leakage of this. So this is, and then the other one is in terms of seismic activities which will affect the groundwater system. I don't think it's something of serious concern. I think, in terms of my own assessment, that is not something that should be of real concern to us. So those are the four issues which I feel, in terms of the site itself, could influence the groundwater resources. And of all the four, you see that my own assessment is that it is the leakage from some of these storage devices which contain very dangerous chemicals seeping into the groundwater system. I will now look at the second aspect, which is the exploration activities itself. What happens is that when fracking takes place, you normally will pierce through with your well. You normally will go through your well. Your well will normally go through the groundwater itself into the shale. Are we together on this one? It will normally go through. It's possible that as you pierce through, groundwater will seep into the shale formation. Are we together? In the process, you lose the groundwater system itself. That is a thing of concern. Not a serious concern, but a thing of concern. That is something of concern. In other words, you will lose your groundwater because of the fact that you are drilling through your groundwater into the deeper formations. That is of concern. I did say that when you drill in the Karoo, water generally will rise. So when you drill into the lower formations which contain saline water, it's possible for the saline water to actually rise to the groundwater which is on top. And that is something of concern. It's of concern, but there are ways that you can mitigate the effects. Not a serious concern, but something of concern. In which case, saline water could actually pollute the groundwater itself. This is of serious concern in terms of leakage of gases and chemicals through the steel casing and the grout itself. The steel casing and the grout itself is of serious concern. And if you look at this diagram carefully, you will discover that it's possible over time for your steel casing to be breached, for your concrete grouting to be breached, in which case then chemicals, hazardous chemicals, which you're using for the drilling, for the shale prospecting, shale gas prospecting, could actually infiltrate and get into the groundwater system. That is something of serious concern. And we have examples. There are cases within the United States where this has happened. There are cases in Canada where this has happened as well. That is something of serious concern. Because you're dealing with a gas. You're dealing with a gas. You're not dealing with a fluid. In terms of its mobility, it's extremely mobile. So it's possible, it's very possible, that methane gas, which could cause an explosion, methane gas, when you are exposed to it over a long period of time, could cause suffocation. Methane gas, when you're exposed to it for over a long period of time, could cause you to choke, and it could also bring about breathing problems. And methane gas is one of those gases that is prevalent within the shale gas exploration. It's possible for that to actually go through the lining between the, what they call the steel casing, and as well as the grout, or between the grout and the formation itself. That is something of serious, serious concern, and there are incidences where that has actually taken place. And what happens is this. So most of the companies will say, fracking is not dangerous. The only thing that is dangerous is this, that when you do it poorly, then this could occur. The question is, who will guarantee that a poor workmanship will not be done? Within the storage facilities, you have contaminated water. What happens is that when you do fracking, you have return flows back to the surface, and those flows are actually contaminated water. You've got to store them. You've got to find ways of disposing of them. And for that to contaminate the groundwater itself is something of concern, and it's something that could actually take place. Invasion of gases and chemicals through induced fractures overlying the groundwater and small earthquakes coming up. Let me use this. I have a small sheet of paper there. This is more cardboard. These are the shales. I consider this to be the shale. And then your groundwater, which is there. You agree with me that the strength required for me to tear this, if I tear this like this, continuing with the tear is much easier. Your first problem is to start the tear of this particular paper. Are we together? That's how the fractures are within the shale formation. The shale formation is a consolidated formation with very, very few fractures. And what happens with fracking is that you then create fractures. You then begin to create fractures like this. You then create fractures like that. Are we together? To propagate these fractures to the groundwater becomes extremely easy because of the fact that what? You have initiated the fractures, which were not there originally. And that is something of serious concern. In other words, for you to then to propagate these fractures right to the top is much easier having initiated it. in the first instance. And that is something of very serious concern. And there are instances in the in the UK, for instance, where small tremors have been observed in areas which before never experienced tremors and earthquakes. So this is what I have illustrated here. These are the fractures these are the fractures you induce within the formation. And then to propagate them further to the surface might be extremely easy because you've initiated the process. Then there is the aspect of decommissioning. We would like a situation where we do not have the acid mine drainage in Gauteng. You don't want that. There's closure. You then have a state where you have to close some of these wells, some of these production wells. What do you do in such instances? Leakage and spillage of contaminated water in storage into the groundwater, that is a serious concern. That's a serious concern. That's how it is. That's how the well will look like. And for it to seep into the groundwater system, definitely, it's something of serious concern. Of leakage and spillage of stored chemicals into groundwater is also possible, and it's something of serious concern. After you have, because a lot of contaminated water will get to the surface, it's very possible in the process of transferring that water to the disposal site, there could be issues that could arise. Spillages and residues during and after site cleanup, that is something that could happen. I wouldn't consider it to be very serious. If it's carefully done, it's possible that you will not contaminate the groundwater resources, but it's something that we should always be aware of. Leakage and spillage of contaminated water during transport to disposal sites. It's possible as you're transporting all these chemical, all this contaminated water to the disposal site, it's possible that you could have pollution taking place. Poorly sealed wells resulting in upward movement of gases and chemicals into groundwater is extremely possible. It's extremely possible. You see, what happens is this. These production wells still have gases in them under tremendous pressure. And usually you seal them with mud. And if you don't seal them properly, they will eventually get to the surface. And that's something of serious concern. Poorly sealed saline water supply boreholes leading to aquifer contamination. In other words, those aquifers which have been drilled in the saline region contaminating the groundwater, it's very possible. I will now like to just talk about my final slide. And in this slide, I like us to look at issues we could demand from our politicians. The first of them is this. There should be a full public disclosure of all chemicals used in the fracking process. That we shouldn't negotiate. If we negotiate that issue, you will find that the companies which do the exploration will take us for granted. There are some of the chemicals that are extremely dangerous to human health and public health. And there is a need for us all to have a public disclosure of those particular chemicals. Number two, the source of water required for fracking should be identified before licensing to exploit or explore the gas is granted, since water is a limiting resource in the Karoo. Number three, there is the need to have groundwater monitoring boreholes where you monitor the quality of the water before the fracking, during the fracking process, after decommissioning, such that you can see a trend whether there is any contamination taking place. That we shouldn't negotiate. And the fourth one is that this should be done by an independent body in terms of monitoring the chemicals. It shouldn't be done by the prospecting companies. It should rather be done by an independent body set up to ensure that proper monitoring is done. And thank you very much.